All right, so we'll talk about parabolas, and the basic parabola is created using y equals, for quadratic equations, right? The basic quadratic equation is y equals to x squared. Now, and that's the graph of y equals to x squared. So let's talk about the features of parabola, right? So the first feature of parabola is its shape. Now, shape could be a smiling face, popularly, you know, easy to remember, and then the other one is a sad face. Now, the smiling face parabola, if I draw the axis, this is how it is. If this is x and this is y. Shout me if you don't understand, okay? Now, this is x and this is y, so this is how that parabola looks like. So it is going up, basically. The mouth is the mouth is facing up towards the positive side of y, right? Now the other shape is with something like this. It goes towards the negative shape of y, negative x's of y. Now, how do you find that your parabola is a positive, is a smiling face or a sad face? The coefficient of x square tells you the story. So if I have a parabola for a graph y equals to 2x squared, the coefficient of x is positive 2, correct? So it's going to have something like this. But then if your parabola is y equals to negative 2x squared, so coefficient of x squared is negative 2. So it's going to be something like this. So always look for the coefficient of x squared to find whether the parabola is a smiling face or a sad face, happy face or sad face. Okay, that's number one. First feature. Now, feature number two is the intercepts. And I'll take another page to explain that. Intercepts. Let's talk about the y-intercept. Y-intercept is the point where the graph touches the y-axis. For a parabola, there's always one y-intercept. Always. Whether that's happy face or smile or sad face. So for example, if you look here, a happy face, you still have, the parabola cutting the y-axis, right? And if it is sad face, it would still be cut the y. You see here, it is still cut the y-axis. One of the arms of the parabola will cut the y-axis, right? This is negative side of the parabola, right? And how do you find the y-intercept? You just equate or you substitute x equals to 0 and you get the value of y-intercept. So for example, if I have an equation, a quadratic, y equals to x squared plus 1, the coefficient of x squared is positive. That means it will be a happy face parabola. And if I ask you what is the y-intercept, plug in x equals to 0 here. So you have y equals to 0 squared plus 1, which makes it 1. So that means 0, 1 is the y-intercept of the parabola that you're dealing with. Right? Simple. Now, let's talk about the x-intercept. Now, x-intercepts can be of three types. Number one, two x-intercepts, two intercepts. Number two could be one x-intercept. And number three is zero x-intercepts. Let's see how the graphs will look like. Now I'm taking a happy face parabola as an example here, right? So this is yx, and if I were to draw a parabola that has two x-intercepts, this could be one. You see here, it is cutting the x-axis in 2 points. Easy. Now, one y-intercept. This is x, this is y. It will be, the graph will just kiss the x-axis, touch the x-axis. So you have just one value of x-intercept. And the third one is 0 x-intercepts. This is x, this is y. You see how this is going to be. It will not touch x-axis at all. All right? 3 possible cases for x-intercept. In all the cases, how do you find the x-intercept? The way we found y-intercept by plugging in x equals to 0. Similarly, if we plug in y equals to 0 in the equation, I get the x-intercept. So for example, if I have equation y equals to x square minus 4. Let's plug in y equals to 0, but let's see what we get. 0 equals to x square minus 4. So x square equals to 4, which means x equals to plus 4 minus 4, right? Because why did I say plus 4 and minus 4? Because square of plus 4 will square of plus, so now this is, sorry, this is 2, my bad. Plus 2 and minus 2, right? So square of plus 2 will also be 4, and square of minus 2 will also be 4. That is why I am taking two values. Now in this case, I am dealing with a case where my graph has two x-intercepts. Here you see plus 2 and minus 2. This might be the case. And similarly, you could have various other cases. Okay, so these are intercepts. Now let's talk about the third feature. And the third feature is the turning point. Very important. Every parabola has a turning point. There are two types of turning points. For the happy face, that's the point where the graph turns back. For the sad face, very similar, the point where it turns back. Now this happy face parabola's turning point is called minimum turning point, and this is called maximum turning point. Why that is the case? If I make a happy face parabola, this coordinate, the coordinate of the turning point, is the lowest on that graph. There's no other point which is lower than this turning point, right? So that is why I call it as minimum turning point. Whereas in a sad face graph, the turning point is the peak of that graph, the highest point on that graph, correct? So that is why it is called the max turning point, and this is called the min turning point. Okay, so you should know this as well. Now, how do I find the turning point? So let's look at this example here. See, my blue dots are my x-intercepts, right? And if you see this turning point here, this turning point is actually sitting right in the middle of my x-intercepts. So if I know my x-intercepts and I find their mean value, I can get the x coordinates of the turning point. So what does that mean? Let us say I have a graph and my turning point, let's say this was -1 and this is 4. That's my turning point here. I need to know, and let's say this, I need to know the x value of this turning point, this point, right? So what I'll do is I'll find the mean. So I'll add both of them, both of these intercept values. So I'll say -1 plus 4, and mean is you divided by 2. So this will be 3 over 2, which is 1.5. So that value is a positive 1.5, right? So your turning point, the x value of your turning point is your intercept 1 plus your intercept 2 forward divided by 2. And these are x-intercepts. It can't be y-intercept because y-intercept's only 1. Right? Now, the last bit, which is axis of symmetry. That is the last, but the most important, one of the most important features again. Axis of symmetry means a line on the graph that divides the graph into two mirror images. So for example, if you've got a graph like this, if I draw a line right in the middle, you see here, is it not dividing? If you look at the left side of this line and if you look at the right side of this line, they look mirror images of each other. You call this line as axis of symmetry. Let's say this turning point was hypothetically 6 comma minus 1. Let's say. So axis of symmetry is a line, and every line has an equation. And since this line is parallel to y-axis, that means this equation would have just the x value, which is constant and not changing. So what is the value of the turning point here? What value of x is constant here? This line, 6, right? You go anywhere on the graph. Your y is changing, but not your x. And hence, the equation of symmetry, or the equation for the axis of symmetry, is always x equal to something. What is that something? Look at the turning point, pick up the x value of, not the x-intercept, the x value of the turning point. So x equal to 6 is the equation of symmetry. Does that make sense? All right. So 5 features, so basically 4 features of the graph, shape of the graph, the intercepts x and y. The intercept y is always, there's always one y-intercept, and there are 3 different cases for x-intercept. And then you've got a turning point. Turning point for the x value of the turning point lies exactly in the middle of your x-intercepts. And the last is the equation of symmetry. That is the line that divides the graph, the parabola, into the mirror images on the left and right. And what is the equation of that axis of symmetry? You say x equal to the value of the x of the turning point, right? So that summarizes in a very nutshell what are the key features of a quadratic equation, a parabola, right? A quadratic equation gives you a parabola eventually. Cool. All right. Awesome. Thanks.